Welcome back to my 3D printer build log. It's been a while again, and there have been some changes. Let's get right to it. I originally intended to have no mains power inside my printer, so I bought this very beefy 600 watt power supply and designed and then printed a two-part enclosure. On the mains side, it has a combined fuse holder, plug and main switch, and I've also tuned the fan so that it doesn't sound like a hovercraft taking off anymore. On the output side, it's got a voltage and current meter and a power connector that is able to safely conduct the currents that I intended it to supply. But as I said, changes were made. The silicone heater mat that you saw me install a few videos ago is a 230 volt version. This means that I had to bring mains power to my printer. Physically separating printer and power supply was no longer practical. On the positive side, that reduced the power consumption of the 24 volt component so much that I was able to use a much smaller and much cheaper power supply. The other one will go back onto the shelf for a future project. The next thing I did was add some padding to the outside of the maker slide brackets. I've used this adhesive foam strips left over from some drywall construction, mainly for two reasons. I'll be mounting the enclosure walls onto the brackets, and I want to have some kind of dampening so that they won't start to rattle around. Also, I want to keep the ability to fine-tune the mounting distance of the enclosure boards. The maker slide brackets will hold narrow panels. For the other sides, I have printed and mounted these brackets. They are covered with foam pads as well. I did all that off camera. The narrow plates do not carry any components and are simply screwed into place with 6 screws each. This is the left rear wall. As you can see, I've already pre-drilled the mounting holes. This is the back edge and this is the front. The power supply will be mounted with 4 screws. This is the base frame for the power supply cover. It will be mounted onto the wall approximately like this. This is the base frame for the power distribution cover. I had to split the primary side cases into 2 parts due to the limited build volume of my printer. The first thing I will have to mount in here is the solid state relay to switch the heated bed. It came with a heatsink and will be mounted like this. Next up is the mains connector, fuse and switch assembly. It will be mounted to the wall of the case approximately here. This is the terminal strip that will make wiring this side a lot easier. And some mysterious component. This is the lid of the power supply case. It has ventilation slots at the bottom and a cutout to pass the cables to the other side of the case. The other case has a hole to mount the mains connector. The walls are partly reinforced to have more material to thread into. The mains connector is simply mounted with 2 screws. The base frames have threaded holes in the vertical pillars that the lids are fastened to, and nuts in the base struts to hold them against the enclosure. As I've already introduced the components, here is a time-lapse of the assembly process. I've got 2 low voltage connections in this area, the thermistor of the heated bed and the control voltage to the SSR. In order to keep them fixed in place and isolated from the mains connections, I'm using these 4-pin Molex connectors. That's where the mystery component comes in. It's a bracket to hold the Molex connector in place. Now it's time to mount the base frames of the cases. Pro tip: when using a paper towel to protect the enclosure wall from being scratched in the vise, make sure it doesn't get caught underneath the component you're mounting. Now for the wiring. I've labeled the cover of the terminal strip to keep things nice and organized. The power supply is connected to the terminal strip on the main side. The 24 volts connections will be threaded through the hole in the enclosure wall. The bed power circuit is neutral to bed, then bed to SSR and SSR to live. The bed cable will be threaded through the other hole. It's unlikely, but in the case of a failure, the metal SSR backplate and thus the heatsink might become live at mains voltage, so I'm connecting the heatsink to the PE here. The mains connector needs 2 short jumper wires from the plug and fuse to the switch, and then the longer cables to connect it to the terminal strip. Always make sure that the PKE connection is the longest cable so that, should the connector ever be ripped out of the case, it will be the last one to come loose. And that's the first part of the wiring completed. Let's test fit the lids. Here I'm mounting the enclosure wall to the printer in order to connect the heated bed cable. Another precaution motivated by the redesign. In the event of a heater fault, the whole bed might become live at mains voltage as well. As a safeguard, I'm adding an earthing connection to the mount of the heated bed. Here I'm connecting the 3 cables grounding the stepper motors. And here is the PE connection to the bed. Now for the low voltage connections. Don't worry, these 24 volt cables are just provisional and will be replaced. Here's the Molex connector with the thermistor wires and a short cable to the SSR input. Off camera I also added some thermal paste between the SSR and its heatsink. Now close the lids. And let's just do a quick test run here. I've got a power meter between the mains and the printer, and I've got my multimeter set to volts just to check the correct polarity of the 24 volt supply. At the moment the printer is drawing about 7 watts and the heated bed is roughly at room temperature. Here I've switched the multimeter to resistance mode and connected it to the thermistor, and I'm using the 24 volts to switch on the SSR. You can see the thermistor value starting to change almost immediately. The power meter is rather on the slow side and takes a few seconds to update. The bed heater is rated for about 450 watts, which is what we're seeing, and after applying a bit of blue tape to the bed to reduce its reflectivity, the IR thermometer starts to cooperate and gives a value of about 70 degrees centigrade after just about a minute of operation, which is not bad for a massive machined aluminium bed. And that's it for today. Next up will be the other backside with the electronics. I will have to do some redesigning work there as well. And as you might have seen in my sneak preview video, I have another TimeSync project going on in parallel. If you have any comments, please leave them below, and if you liked the video, please give it a thumbs up. And please subscribe to get notified of new videos. See you later!